Welcome to the Silicon Image Dual Screen webinar. We are recording this, and this will be posted on the Dual Screen Challenge website as well as Silicon Image's website. So, who is Silicon Image, you may be asking? Well, first let's talk about the Dual Screen App Challenge, which is the driving force behind this webinar. As you may be aware, we're having a contest to find great apps that run in dual screen mode. This is, as we all know, which is why we're here, an Android capability that Mark will go into in great detail. We have, excuse me, we have a $100,000 prize pool, and submissions are being accepted in 3 categories: games, productivity, and entertainment/other apps. We have a world-class panel of judges, including myself, Magnus Eckenheim from Sony Mobile, Mark Murphy, who you know well, who will be speaking in a moment, Mike Schwartz from the Application Developers Alliance, Neil Trevitt from NVIDIA and the Kronos Group, Crispy Uccello from Google, and Mike Yuen from Qualcomm. The submission deadline is July 21st, so a little bit over a month, and you see the website there, siliconimage.challengepost.com. Log on today, register for the challenge, and that way you will get updates and alerts and be able to find other team members, submit your application, and win part of the $100,000 prize pool. Silicon Image is the company that drives connectivity standards. We're a leading semiconductor and IP provider of HP connectivity, including brands that you know very well, like HDMI, and some of our newer technologies, including MHL and wireless HD. We target mobile, consumer electronics, and PC, and we're headquartered in Silicon Valley, in Sunnyvale. I'm going to talk briefly about MHL and wireless HD just to give some context before I turn it over to Mark. MHL is the de facto industry standard for connecting an Android mobile device to a big screen, whether that be an HD TV or a monitor. It's a powered connectivity, so the monitor or TV actually sends power back to the phone to keep the phone charged and charging while it's connected. At the same time, the phone is sending video and audio up to 4K at this point with MHL3 back to the TV. I don't know if any of you were at CES, Game Developers Conference, Android Developers Conference, or E3, but we've shown our 4K demo, or Mobile World Congress actually in Barcelona in February. We've been showing the 4K over MHL, and it's very impressive. MHL3 was announced late last year, and MHL is, when I say the de facto standard, I mean it's already in 500 million devices on the market already. Strong presence in both mobile and consumer electronics. 10 of the top 15 I believe it's actually 11 of the top 15 smartphone brands have adopted MHL. And of course, Silicon Image technology is in 9 out of the 10 top digital television manufacturers. The use cases for MHL are constantly expanding, and that's what I'm counting on people who are entering the contest to show us. Gaming, of course, your phone becomes a game console with a wireless controller and a TV. Productivity, wireless keyboard and mouse, and a digital monitor. Your phone has more power than your laptop did 5 years ago. Home entertainment, streaming videos, watching movies, karaoke, whatever you have you. Automotive, MHL is very involved in some newer automotive initiatives, and you will see more of that coming from manufacturers. And it's already in a lot of aftermarket headsets and automotive products like from Pioneer and Harman Kardon. And of course, streaming and everything else. Wireless HD is an interesting wireless solution. This is actually wireless in the 60 gigahertz range, so well above Wi-Fi. There's no interference from 2.4 or 5 gigahertz Wi-Fi. So it's shorter range than Wi-Fi, but much higher bandwidth. It's great for in-room cable replacement. It has beam steering, so it will actually bounce off the walls and off the ceiling to find the best path from the transmitter to the receiver. And again, we've been showing this a lot if you've been to any of our trade shows. So 0 latency, full fidelity, low power solutions available. It really is an innovative and remarkable wireless solution. And with that, now that we have an idea of who Silicon Image is, what wireless HD is, and what, of course, MHL is, I'm going to turn this over to Mark Murphy, who will give all the technical information you will ever want to know. And again, if you have questions, primarily for him, but also for me, please type them into the Everyone room in the chat window, and I will address them to Mark at the end of the session. Mark, over to you. Oops, sorry, I need to unmute you. All right, you're live.
Okay, hopefully everyone can hear me. Again, this is Mark Murphy. I'm the author of the Busy Coder's Guide to Android Development. You may also know me from places like Stack Overflow. I'm on this Commonsware there, a number of open source libraries for Android development. We'll talk about one of those here today, and so forth. And so basically, my job here today is to talk a little bit more from a technical standpoint about what it takes in order to do your Android development with external display support, whether you are looking to participate in the Silicon Image App Challenge or just for general purposes. As Michael said, if you have questions, use the chat tool. And that feel free to ask them. Either I'll take them in the stream or we'll address them at the end. And that also there will be a URL that I'll provide you at the end of the presentation where you can download the slides that I'll be showing here, plus links to some of the sample code that I'll be talking about, and so forth. And with that in mind, let's start talking about external displays. When I refer to external displays here for Android development, I'm referring to an auxiliary screen, something that is secondary to the primary touchscreen of your Android phone or tablet. And therefore, it's inconsistently available. Sometimes the user will have one of these external displays available. Sometimes they won't. Perhaps they have their home set up and that for external displays, but they're not always at home. They're at work. They're in transit somewhere, and so therefore they only have just the primary display of the touchscreen. Generally speaking, these external displays are display only. I'm not aware that the Android has the drivers to support touchscreen enabled displays. MHL does support being able to provide input from, say, a television style remote back to Android. But certainly from a touchscreen standpoint, you're not going to be seeing that in the here and now, though I believe people are working on it. I'm not referring to things where we simply happen to have an Android device that is plugged into the TV as its primary mode of display. Your Amazon Fire TV, Ouya game consoles, various Android HDMI sticks that you can get from eBay, Alibaba, and elsewhere. The television is the primary display, replacing the touchscreen that you see on the phone or the tablet. And developing for those is more traditional. You're going to be using standard UI techniques, creating your activities and so forth that just happen to show up on the television. I'm also not referring to independent smart devices that you might be driving or otherwise controlling from a phone or a tablet, such as Chromecast. In those cases, your application isn't really working with the external display directly. It's going through a third party, the Chromecast dongle or whatever, and then there's different protocols that you talked about. That being said, there are many, many ways for Android devices to work with an external display. While your Fire TVs and Chromecast seem to get all of the tech media love, in reality, as Michael pointed out, there are many, many more devices, many, many more users out there who are capable of hooking up to an external display today than merely the handful that have Chromecasts, Fire TVs, and so forth. Some Android devices will support HDMI directly. Usually that will be in the form of a micro HDMI port. So like your Nexus 10 has a micro HDMI port. You can get a micro HDMI to HDMI cable to plug that into a television, projector, monitor, or whatever. Michael already spoke regarding MHL, MHL3, and that this overloads the micro USB port on many Android devices, where with an appropriate adapter, you can convert that to HDMI, or there are televisions and monitors that support MHL native. You can get a direct MHL to MHL cable. We've talked about those. You'll also hear about SlimPort. SlimPort is a similar concept in that it overloads the micro USB port, and that to allow you to set up a SlimPort to HDMI adapter to be able to connect to an external display. From a market share standpoint, MHL rules the roost. You as a developer may be more familiar with SlimPort simply because, for whatever reason, the Nexus series devices have gone the SlimPort route. Nexus 4, Nexus 5, Nexus 7 all support SlimPort. And since the Nexus devices are popular amongst developers, it's conceivable that you're going to have SlimPort, even though many more of your users would have MHL of those two competing approaches. There's also wireless protocols. The one that has the numbers at the moment is Miracast, also branded by Samsung as AllShareCast. This uses Wi-Fi Direct as a transport means for a display protocol. The downside of Miracast is that it is a compressed format. This is going to introduce some latency, some lag in the delivery of the content to the television. For many apps, it's not going to be horrible lag. First-person shooters and similar sorts of games, fast twitch games, it's going to be a bit more of a problem as there's going to be some amount of lag between the user pressing the trigger on their controller and then the effects of that showing up on the screen, enough that it may cause some discomfort amongst gamers. Various manufacturers have their own proprietary or manufacturer-specific approaches. Samsung, some of their tablets, they overload their own 30-pin connector, where you can buy from them a HDMI adapter for it that allows them to speak HDMI. And wireless HD, as Michael pointed out, is an up-and-coming contender in this space. Unlike Miracast, wireless HD is uncompressed, no lag, and so therefore it's going to be a very strong player, and that in the fullness of time. From our standpoint as programmers, though, it doesn't really much matter. Other than the Miracast scenario of the lag, it's all going to be largely the same from what we see as programmers and what our users wind up seeing after they have hooked their device up to the television. On Android 1.0 through 2.3, in other words, ancient history from an Android standpoint, there was little to no support for these external displays. Every now and then you'd run into a device that offered something. HTC's Droid Incredible took a similar concept to the MHL and SlimPort approaches where they overloaded the micro USB port, but it was their own tech as far as I know, and it outputted composite output, the red, yellow, and so forth cables and that RCA style plugs, and that with an eye towards predecessors to your modern digital displays. Android 3.0 inaugurated a formal support for external displays inside the operating system, though through 4.1, this was largely limited to full-screen mirroring. Whatever you'd see on the touchscreen would show up on the external display, which is fine for some circumstances, but not necessarily an ideal use of screen space. Particularly, it might be nice to be able to show something different on the external monitor as opposed it is to what you're showing on the touchscreen, using the touchscreen more as a focus for input and the external display the focus for output. A few things like video players would have ways of being able to drive the external display directly, drop their content there, but it wasn't general purpose. That showed up with Android 4.2. And nowadays, Android 4.2 is a significant percentage of the Android device ecosystem, and so therefore, the things that I'm talking about here today, which are focused on Android 4.2 and higher, and that become candidates. Though bear in mind that not all device manufacturers did a great job when they upgraded devices to 4.2. Some devices that were upgraded to 4.2 will work just fine, driving the external displays separately. Others will not because the manufacturer loved the upgrade. Of course, the output that we are getting is different than the input that we are, or rather the output that we are doing on the touchscreen. Televisions will run with different screen resolutions, 720p, 1080p, 4K, and so on. And they'll have different densities. 720p is often considered TV DPI, 1080p, HDPI, trying to take into account the fact that people sit a lot further away from the television. And in general, we don't necessarily know, depending upon the display protocol, the actual physical size of the screen, let alone the user's distance. The key is that we need to consider what context objects we're using when we're loading in resources. Normally, when you're loading in your resources, your layouts, your drawables, and so on, you're using the activity as your context for retrieving those resources. That way, you're going to be not only taking into account standard activity themes that you've set up for it, but also the activity knows the screen size, screen density, and so on of the touch screen, and will give you appropriate resources. So you have ones that are tuned for phones versus tablets. When you are working with external displays, there's going to be a different context object that we're going to be handed, specifically so that we can request resources from it, and it's going to give you resources that are more in tune with the external display that you are talking to. And so the fact that you happen to be a phone talking to a television versus a tablet talking to a projector, and that it's going to take the television and the projector and the monitor more into account as opposed to the native capabilities of the touchscreen, which don't really have much impact on what is shown externally. And so you'll use the right context in the right places. The classic key class from the Android SDK standpoint for being able to drive these external displays independently of what's on the touchscreen is a class called Presentation. This is a subclass of dialog added in Android 4.2, API level 17. You set it up much like you would set up a custom dialog. Override on create, call set content view to load in a inflated layout or a layout resource or your own custom views, and that's going to drive what's going to show up. When we work with a presentation, we're going to teach it the context that we want to use for resources for that presentation, and it will be a context that we're going to get associated with a display object. The display object representing the external display itself. With a dialog, when you call show on a dialog box appears, floats over top of the activity. When you call show on a presentation, the content that you set up with set content view instead will display on the external display, as indicated by the display object. And therefore, we are going to be able to go in and drive the drive the external content independently. Now, there's a fair amount of boilerplate that's involved in dealing with this presentation stuff. We have to know when when displays come and go. Our application may start up. There may not be an external display yet. Then they go in and plug in the cable or use settings to configure the wireless options. And all of a sudden now, we do have a display. Or vice versa. We had been talking to a display, and now all of a sudden the user wandered away, and therefore we have no display available. And similarly, our activity that is looking to use this presentation can come and go from the foreground. And so I've wrapped up a lot of that boilerplate code in a class called Presentation Helper. This is in my CWAC presentation library, and there'll be a link for that in the web page I'll steer you to at the end of the presentation. Presentation Helper is fairly straightforward. You'll create an instance, usually an on-create of your activity, give it a context, probably the activity itself, along with a Presentation Helper listener. That's going to go in and be able to indicate that, all right, this is what we're going to use as a listener to find out about various events and that they go on in the life cycle of our presentation. You forward the on, pause, and on resume lifecycle methods on to the presentation helper, and that listener will then be called with show preso and clear preso methods. Show preso means it's time for you to show a presentation. We have an external display. We are in the foreground. Clear preso will be if that state changes, and either because we're going away or the external display went away, we should clean up from the presentation that we had been displaying previously. With that in mind, let's look at some code. I have here a little activity. It implements that presentation helper interface. You don't have to implement it on the activity. You can implement it on something else as appropriate. Just to keep it simple, I implemented it here on the activity. In onCreate, in addition to setting up the UI for the activity, I create an instance of that presentation helper, passing in my context, the activity, and my listener, also the activity. And I forward along to that helper the on resume and on pause methods as part of the overall lifecycle process. Then my show preso method, when I'm called with show preso, it's time for me to display a presentation. I have a simpler presentation class we'll look at here in a moment. That is a subclass of presentation that knows how to display a little bit of content. Its constructor takes a context, the activity, and the display object that we're passed in show preso, indicating what external display we are addressing. Note that in principle, the Android APIs for this are set up that we could be talking to several external displays. And that's not out of the realm of possibility from a technical standpoint for people. They could have one set up with a wireless protocol and one set up with an HDMI or MHL cable. I haven't personally tested that scenario yet, and so I don't know how well it works. But it's all within the realm of possibility, and that we should get separate display objects for those different external displays. And therefore, if you are interested in taking advantage of that, showing different content, and that per display, you'd pay attention to that display object and decide what to show accordingly. In my case, I just create the simpler presentation and call show on it, like I would call show on a dialog. Simpler presentation extends the presentation class, and in onCreate, I call set content view. In my case, to load up a web view that I am using to load up my own site's homepage, commonsware.com. Now, I could be going in and loading up something else. I could be, inflating a layout and using that with set content view myself. I could be just passing in the content view's resource ID and using that with set content view. In my case, I elected to create it in Java code. That is certainly not required. Given that you actually have some code that's supposed to be driving an external display, it'd be nifty to determine whether or not it actually worked. For long term, by the time you start shipping, you're going to want to be able to really talk to an external display. You're going to want hardware that is capable of talking to an external display. You're going to want a television or a monitor or a projector or something that you can use for testing purposes. From the device standpoint, as Michael pointed out, 500 million Android devices out there support MHL, let alone some of the other options. And so therefore, the odds are, if you have Android hardware and it's reasonably modern, then you probably already have the capabilities of speaking to an external display. It's merely a matter of making your connections and having the display to talk to. Personally, I happen to use a little Pico projector, and that I shoot to an adjacent partition of sorts, and that to use. That way it doesn't take up a whole lot of desk space. The projector is about the size of a paperback book. But there's nothing stopping you from hooking up to a regular television, hooking up to a monitor, a larger projector, whatever you happen to have lying around. But in the short term, And particularly for lightweight debugging, it may be inconvenient for you, given your desk setup and all that, to be plugged into an actual external display. The good news is that it is possible to simulate that. If you go into developer options of your Android device, you will have an option for simulate secondary displays. Tapping on that, you can teach the device to pretend that there is a secondary display. Uses GPU overlays to float over top of the main stuff that you are displaying in your activity, a little transparent window showing whatever it is that you are pushing to the external display. And as a result, you wind up where you'll be able to see simultaneously both things. That window, at least on newer devices, can be slid around. You can, while you can't tap on elements in what you're showing in the external display, it doesn't respond to touch input that way. You can drag and slide that little floating panel around to move it out of your way. Because the downside of this approach is that it does occlude part of what's on the touch screen. You can't see your activity very well behind the little overlay. It also requires hardware by and large. The 4.2 x86 emulator works with it. I haven't had much luck recently with the 4.3, let alone the 4.4 x86 emulator, and that's driving the external displays simulated. And the ARM emulators, forget about it. And that glaciers will move faster. And so it is sort of thing where you're probably going to be wanting hardware for, but you don't necessarily have to be plugged into anything or have the external display physically somewhere around. You can simulate it. Under the covers, there are a couple classes that Presentation Helper could be using for finding out about these external displays, when they come, when they go, and what they're there. The one that Presentation Helper actually uses is called Display Manager. This is a system service, called Get System Service and Ask for the Display Service, much like you work with other system services like Alarm Manager, Notification Manager, and so forth. You can then, on that Display Manager, call Get Displays to get a list of all of the displays that are presently connected, either all of them fully or ones that are a particular category, of which, last I checked, there's only one category, Display Category Presentation. This indicates that you're looking for an external display that is designed for presenting content, in case there are several options and maybe only certain ones are optimized for that scenario. You can also call Register Display Listener to provide a listener to the Display Manager. That listener will be informed when it is time for external displays to come and go. Stephen, if you could you mute yourself on your end, and because you are bleeding into the background. Thank you. So you can call Register Display Listener in order to find out when external displays come and go. Presentation Helper under the covers is handling that and blending them in with the on, pause, and on resume events to provide a single set of events to use, so that no matter what the reason is why you should no longer be showing the presentation or why it's time to show the presentation, you're notified about it. There's also the Media Router system service. This is another one. You'll call Get System Service, ask for the Media Router service, pass it to be the Media Router, at least classically. Nowadays, there is another implementation of the Media Router, and that in the Android support package, there is a Media Router V7 library project you can add to your Android application. Depending on what you are all doing, you may want to consider using the one from the Android support package. Media Router is designed for a more general scenario, finding routes for audio or video. It supports three major scenarios: live audio, such as external Bluetooth speakers; live video, such as our external displays, television, monitors, and so forth; and the so-called remote playback scenario. which is basically Chromecast and things that work a little bit like Chromecast. You're going to be able to go in and use Media Router along with other classes to be able to drive a Chromecast. And so, whereas Display Service is focused solely on these external displays, Media Router can be used for other things as well. Get Selected Route will tell you what route is currently selected, say, for example, for live video. You can use Media Route Action Provider and Media Route button to provide user interfaces for the user to be able to choose a particular media route, such as, do I want to display content on this external display, and so forth. You can add callback to find out when routes change, new routes become available, existing routes vanish, and so on. While the Media Router class was added earlier, API level 16, at that time it only supported audio. Video was added in API level 17. Remote playback was added via the Android support package. And so again, depending upon your use case, you're going to be looking to either use, you could get away with the built-in Media Router. More likely you're going to want to consider using the one in the Android support package. Now, since presentation extends dialogue, you might think that we could use dialogue fragments in order to be able to set up and manage presentations. And the good news is that does actually work. In fact, my CWAC-Presentation library has a presentation fragment, subclass of dialogue fragment that provides a little extra benefit and that for helping you deal with context. And just like dialogue fragment can either show a dialogue popped up over the activity or in line as a true fragment in your main UI, if you add it with a fragment transaction, same thing works with presentations. The dialogue fragment or presentation fragment can either show the content on an external display or show it in line as part of your main UI if you simply use the fragment as a fragment as opposed to thinking about it as managing a dialogue presentation. This is great for being able to conditionally adapt to circumstances. Some apps will only make sense if there's an external display. Most apps, you probably want it to work even when there isn't one. And so you want to be able to show things on the external display if you have it, but that same stuff, or much of it, you're going to also want to be showing on the touch screen if there is no external display. You may be able to use fragments in order to be able to have that all run from a single implementation. However, the downside is that we are dealing with different contexts. There is the one context that we use being the activity itself. For the inline fragment, a different context associated with the external display when we're showing the presentation. So we can't readily use the same dialogue fragment instance for each scenario. You will wind up replacing the dialogue fragment using one instance for showing on a presentation, a different instance for showing in line to make sure you're getting all the right resources. So you can share some of the code. There will be a little overhead compared to some of the other fragment work that you might be doing. For example, the first time I delivered a presentation on this topic was last year at the Samsung Developer Conference out in San Francisco. And there I was delivering the presentation from a Samsung Galaxy S4, hooked up via NHL to a HDMI-equipped display. I had my own application that I was using for driving the slides. Up until this point, the audience was simply seeing slides, not significantly differently than what you've been seeing here. But then, all of a sudden, I toggled something in my application, and they saw what I was seeing. I turned off the presentation and switched to normal device mirroring. Now, they were seeing both. They were seeing what I was seeing, a view page with an action ball. And here we're seeing a screenshot showing a simulated external display. And so in the upper left-hand corner, what we are seeing is I've gone in on this particular device, toggled on simulated external displays. And so in this mode, the audience was seeing that little slide, that we're seeing in the upper left-hand corner. But of course, they were seeing it on a large projection screen. and that here I just have this showing how the simulation works. That panel can be slid around in order to move it out of the way in case you, for example, want to interact with your home button in your action bar. But also, you're going to be I was able to toggle things off and show them what you see in the main window itself, the activity with the view page. So let's walk through how that application works. Once again, I have an activity. Once again, it implements presentation helper listener. Once again, I set up a presentation helper in OnCreate. But in addition, I set up a view pager. Using standard view pager recipes, I've got a pager adapter called Slides Adapter. We'll look at bits of it in a moment. And I'm also using Jake Wharton's tab page indicator from his view pager indicator library for implementing those tabs that you saw across the top of my activity. And forgive the really big fonts on this slide. And that once again, I migrated or forwarded my on resume and on pause events from the activity to the helper, so it knows when the activity is coming and going from the foreground, in addition to using Display Manager under the covers to determine when external display is coming down. When the view pager would change pages, either due to swipes or tapping on tabs, on page selected will get called, and I would tell my presentation, a slide presentation fragment named Prezo, hey, we're now should be showing certain slide content. Specifically, I'm passing it a resource ID of a slide that should be displayed, because all my slides are simply drawable resources in this particular application. My show Prezo method determines what the current page is, what the current slide is that we're showing, and creates that slide presentation fragment. That presentation fragment then is going to be shown. Since I am using it to drive a presentation, I could take that slide presentation fragment and add it as a fragment transaction somewhere. Say that, oh, okay, I want this to be part of the main UI. That's not really the role of this application. This application is specifically designed for two screens, one for the audience, one for the presenter. So I'm using the standard show method on a dialog fragment to show this, providing it a fragment manager along with a tag for this fragment. And in clear Prezo, I'm calling dismiss to say, okay, we don't need this anymore. The presentation fragment itself uses the factory pattern in order to hang on to that resource ID of the slide to be shown in the bundle of arguments associated with this fragment. That way, in case of a configuration change, or I press home and then go back to the application via recent tasks, but the process had terminated in the meantime, I won't lose that ID. Note, though, that display objects aren't parcelable. I cannot put one of those inside of the actual bundle itself. And so for true support for configuration changes, more work would need to be done in this application to handle that. This particular application in the manifest, I set things up that it's only going to be supporting landscape because it was purely for presentation purposes, and that it's not exactly production grade. Just as with a regular dialog fragment, you use onCreate view to indicate, okay, this is the contents of the dialog. Presentation fragment also uses onCreate view. Here I'm setting up a regular image view, setting its content to be a particular resource ID, starting off with that resource that we passed into the factory method. And later on, this is the method that gets called in order to switch to a different slide. So as I use the view pager to navigate between slides, the audience sees the replacement slide because I tell the presentation fragment to update its image view, and that shows up on the big screen. So you're going to be able to go in and say, all right, I'm going to have different fragments or different views that's going to represent my user interface. Some are going to focus on what's shown. Some are going to focus on controlling what was shown. In the context of a game, for example, there's the game output, plus your virtual, touchpads, joypads, and triggers for touchscreens, since not everybody is going to have some sort of a Bluetooth connected game controller they're going to be using with your app. In an external display scenario where you have one, the ones that are providing input you'll be displaying on the touchscreen. The ones that are providing output, some of that would go to the external display. But if the user is not set up with an external display at the moment, they're on the subway, you can show all of that stuff on the main touchscreen, or possibly drop out bits and pieces of it that are only then shown based off of a gesture or a tap on a hotspot or something in order to be able to have it conditionally appear and that when the user requests. There's also techniques for mirroring select content. I have classes in the CWAC presentation library based upon a CWAC layouts library that allow you to specify that part of your UI should be mirrored. So, for example, in a different sort of a presentation app, you might say that, okay, I want to show part of the main touchscreen's UI with the slides and stuff that's being drawn over top of them, but not other aspects of the main UI, such as the countdown time, speaker notes, and things like that. There's techniques for doing that as well. The downside, though, of the presentation class is that it extends dialogue. Dialogues can only be shown by an activity, which means you're going to wind up dismissing that presentation as part of switching to some other activity. And that's going to cause some flicker, because the device is going to flip back immediately to mirroring mode of the whole screen before you get a chance to create and display some new presentation. Similarly, if you try dismissing one presentation to show a different presentation, you'll get the same sort of flicker. As a result, that's going to tend to limit your architecture. You're going to wind up having to go with a fat activity approach. There you've got one activity, one presentation driving the external display. You're swapping fragments around, or you are changing the content views, or you are hiding and showing widgets, or otherwise updating the UIs in place, as opposed to regularly switching between different activities, between different presentations to avoid that flickering effect. It is also possible to drive a presentation from the background, because another limitation of the presentation class itself is that since it extends dialogue, you have to have an activity around, which means that you can't have, with the standard presentation class, you can't be showing something on an external display while the user's off doing something else completely independent of your app on the primary touchscreen. But that would be a nice approach. You'd love to be able to have the video player where the video is showing up on the television and the user's using the touchscreen either within your own UI, participating in chat or looking up things in IMDb or whatever, or off doing something completely independent, browsing the web, responding to a text message, things like that, while the video keeps playing and they can keep seeing it. There's nothing in the Android SDK at a high level that supports this, but after stumbling upon some tantalizing clues inside of some Stack Overflow discussions, I figured out the technique, and I have a presentation service in that CWAC presentation library. You can subclass that, override a build preso view method to define what it is that should be shown, and then the presentation service will detect when an external display comes and goes, and it will show your desired view on that external display when it's available. Then you would wind up using something else, like some sort of an event bus, local broadcast manager, auto, etc., to be able to control that view, be able to send messages to your running service to let it know, hey, go change to some different content or pause the video or whatever based upon user input inside of your activity or from a notification or however you're getting the input. So, for example, the demo presentation service sample in my CWAC presentation library has another version of the presentation slide sample that I used at the Samsung conference, but this time it's designed more for just automatically rotating between the slides, and that while the touchscreen is off doing something else. And so I have a service that I'll use a handler in order to be able to get control every so often to update my slides. Build Preso view, I create an image view, and kick off a post-delayed loop where I will update that image resource with the next slide based on what current iteration we're on, and then use post-delay to get control again 5 seconds later. This doesn't require any user input other than launching the service itself, and then it just sits and runs and runs and runs, rotating through the set of slides until such time as you run out of, you stop the service, or you hit 2 billion, and we, wind up rolling back to, the numbers all over again. That wraps up the presentation proper. You can get the slides that I'm using here. I have a QR code. I am also pasting the link into the group chat tool, and that so you can download the slides, the first 2 sample apps that I showed, along with that CWAC presentation library and the presentation service demo, and the rest of its code is there, and that for you to be able to get at all those sorts of resources.
Thank you, Mark. That was fantastic. I do also want to let people know that we have a 50-page excerpt from Mark's book, The Busy Coder's Guide to Android Development, available on the contest website. I'm actually going to go back. Mark, are you done on the sharing your screen?
Yes, if you need to use the URL, get the URL, feel free to grab it from the group chat. And Michael's back in charge.
Such as it is. So if people have questions, please type them into the chat window in the WebEx application. And in the meantime, I'm going to quickly show the URL, show the website for the developer contest that we're having. As I mentioned, this is the Dual Screen App Challenge, $100,000 prize pool. And as you see the page, we have lots and lots of information on here. If you go to the Resources tab, you will see Mark's sample APK that he talked about, the presentation APK and the code, plus, of course, the excerpt from his book right here that he discussed. And as I mentioned, this contest closes on July 21st, so an excellent time to get your application in is right now and start thinking about it and start developing and finding team members. You have just about a month to get your app in. We have judges, myself, Magnus Eckenheim from Sony Mobile, Mark Murphy, of course, Mike Schwartz from the Application Developers Alliance, Neil Trevitt from NVIDIA, also the Kronos Group, Chris Butella from Google, and Mike Yuen from Qualcomm. So an excellent panel of judges, $100,000 in cash to give away, and we want you to have it. So please start working on your applications and submit them. Register for the, we invite you to register for the contest now. And once you've registered, then we'll be able to send you updates and other information as it becomes available, keep you in the loop like that. So, any questions for Mark? Well, Mark, you are tremendously brilliant. It appears that nobody has any questions. You've covered everything thoroughly. Oh, hold on. Presentation was awesome. Excellent. Yes, please implement it. Get part of our great prize. We're looking forward to seeing your application or applications. And with that, I believe this will conclude the dual screen technical webinar. Mark, any closing statements you want to make?
If you have questions after today, obviously there are plenty of public resources and Stack Overflow, etc. And that where you can get your assistance. People who subscribe to my book also have access to my office hours. I try to hold a couple hours of chats a week to be able to answer any of your Android development questions, and I'd be happy to take questions on external display stuff. And that just be careful, and that again, I am a judge at that end. So please keep your questions general purpose.
Again, that's siliconimage.challengepost.com. If you need to reach me for any reason, it's michael.bergen@siliconimage.com. And of course, you can find Mark at commonsware.com. Question for you, Mark. Has anyone used a good framework for 3D on dual display?
Quite possibly. However, 3D is not my area of expertise, and that in particular, gaming is not my area of expertise. I would hope that your Unity 3Ds and whatnot, and that are looking into or directly supporting these external displays, but in terms of what level of support those sorts of game frameworks and that may offer, that's not my cup of tea. My apologies.
I've spoken to the guys at Unity, and this is absolutely on their roadmap, but they have not yet implemented it. But they are aware of it, and if you'd like to see it implemented in Unity, please let them know, because the more users they hear from, the faster they will move it up on their roadmap and in their priority list. Good question. Thank you. Since I haven't seen any additional questions, I think we're going to call this one. Thank you all for attending, and particularly thank you, Mark, for your excellent presentation. We will get this posted as soon as we can, and the information will be on siliconimage.com. It will be on our challenge post software application challenge website, siliconimage.challengepost.com. Social media, it won't be hard to find. So keep your eyes open for that if you want to review this later. And of course, Mark sent out the URL for his presentation and for the application in the chat window. So make sure you grab that as well. And I hope you used the QR code on screen if you wanted to get the information that way. So now everybody has all the information they need to create compelling, exceptional, magnificent applications and games to blow our minds, wow us, and win prizes. And really, that's all we want. Thank you all for attending, and we look forward to seeing your entries.